I need some MySQL backup strategies and methods. My name is Pep Pla. I'm father of 3 kids and 3 cats. And in my spare time, I'm a consultant at Pecana. And this talk is dedicated to my parents for obvious reasons. Well, why your backup strategy is probably wrong. What's a strategy? Strategy is the skill of making or carrying out plans to achieve a goal. So backups are not a goal. You don't get up in the morning and say, my goal for today is making a backup. Okay? A goal is to protect your data. A goal is to ensure that your business is up and running. A goal even is to uh, achieve legal compliance or some sort of regulation. But backups per se are not a goal. And if they are not a goal, they are not subject of a strategy. You should focus on something that is a goal. And a goal is, for example, recovery. When something happens, you should focus on recovery because this is a real problem. Having a backup is not a problem. Actually, I used to say that if in 99% of your backups fail, but you succeed one recovery, that's fine. If 99% of your backups work, but you fail one recovery, you have a problem. Okay? This is an edge case, obviously. So you should have a recovery strategy. And also interesting the difference for me that I'm not English native, the difference between recover and restore is very interesting because usually when we focus on backups, we focus on restore. We focus on returning something or someone to an earlier good condition. So I have a backup 1 week ago, I restore the backup, that's all. Well, this is not true. Depending on your business, you will restore the data, but your business will not recover because you have 1 week of data loss. Okay? So the really important thing is to recover, not to restore the data. And the problem is that the amount of different things that can happen is huge. You can have a disaster, you can have a criminal attack, you can have a nature disaster, employees that are not happy or are simply crazy, hardware failures, wars, major nature disasters. So, and you can have even combinations of these kind of things, or even situations you can't plan in advance. So absolute protection is impossible. Okay? And if you try, you have to pay a lot of money. So the first thing you need to do is to define the set of incidents or the types of incidents you want to protect yourself. For example, those which are more possible, those that bring higher risk, or just a combination of cost versus risk. So you are willing to assume that a server can crash and the data loss is not bad for you. Don't make backups. This happens, for example, on development environments or test environments, you don't make backups. But it can also happen on old data environments used for reporting. So, well, if you lost that data, you can't do the reporting, but that's something you can live with. And then you have to design the backup restore availability methodologies to ensure that you are able to recover from those different types of incidents. And, well, backups, we can have different types of backups. A database usually consists in two types of files. On one side, we have the DB files, which contain the data. And on the other side, we have log files, which are usually used for to store data temporarily and are used for consistency. This is a drawing of that model. In the log files, writes are sequential and all the transactions are written, and in the DB files, the writes are random. If we want to make a cold backup, what we do is somehow freeze writes, and then we copy everything. Usually, the traditional method to do cold backups was to stop the database. Okay, but you could perform a full cold backup without stopping the database, as long as you make sure that everything has been flushed into disk. Okay. Hot backups copy the data files, ignoring the changes. As we have the data files that contain the data, and we have the log files that contain the changes, what we do is we copy everything without trying to be consistent, and then with the log entries, we make this copy of the data files, we turn it into something consistent. Okay? And there's something I like to call the warm backup. A warm backup.
Sorry, can I ask you a question? So, previous slide. So I didn't realize that, so like what, extra backup doesn't make a consistent backup until it's applied to logs.
Exactly.
I don't know if I remembered that. I definitely didn't remember it.
A cold backup, a warm backup is a cold backup without closing the database or closing it for a shorter period of time. For example, snapshots are a warm backup because you don't close the database, but you need recovery. Okay? And there's also one method which is quite ugly, but can be very effective if you have to make a backup of a huge database, is using, for example, rsync with the database open. And you transfer the huge files that are never modified via rsync with the database open, and then you close the database and transfer the rest of the files. Okay?
I've actually had one scenario where a snapshot that I did while the database was running wasn't consistent. Sorry, it failed to achieve consistency when it came back up.
Well, this depends on the technology used for the snapshot. Probably it was a snapshot in virtualization or GCP. Yes, sometimes this fails because it's not a storage level snapshot. And then it's
not a storage level snapshot?
It's a virtual storage level snapshot, okay? So the problem here is that you need to make sure that different physical storage are snapshot at the same time. So it's the same example that you have, for example, I don't like snapshots because if somebody writes something for whatever reason in a different file system, then the snapshot is not consistent. And you discover this when you, and this happens very often in VMware and things like that, that the snapshots are made on data stores, and for whatever reason the server is using more storage, then you create another file on a data store. The operating system sees those two files as a single disk, for example, or is able to, via LVM, to merge them into the same file system. But VMware has two files, and creating a consistent snapshot of two files placed in two different data stores is complex. Another option, sometimes people tries to avoid making backups by using replication. So I have 20 replicas, no problem. If something fails, I can just promote one of the replicas. But this is protecting us from a reduced set of incidents. And it provides a false sense of protection. If somebody drops one table, it will be replicated immediately. Okay, so if we don't want to replicate it immediately, we can use delayed replicas. How much delay? Because sometimes things happen on Friday, and people realize it on Monday. So 2 days. And if somebody executed an update and corrupted data, so the amount, as I said, the amount of incidents is really very high. So, and very often the delayed replica feels like security. And we have logical backups and physical backups. What logical backup is, usually is defined as generating the SQL code needed to rebuild the database. But this is no longer true. Originally, logical backups in MySQL were performed by MySQL DOM that generated a SQL file that you could run on the database immediately. But this is not happening anymore with advanced tools like MyDumper or the MySQL shell and DOM utilities. What these utilities do is they use the same methods to extract the data than MySQL DOM. This is queries. But this data is stored on intermediate files that do not contain SQL statements. So usually you have metadata plus the content of the database. So I prefer to define logical backup, logical and restore operations that execute SQL code to extract the data in the case of the backup, and SQL code to rebuild and load the data in the case of the restore. Logical backups usually are small in size. In the case of MySQL, they benefit from the MySQL approach to the multi-versions due to the fact that do not require locks. In other technologies, logical backups require a lock at the database level, but due to the fact that repeatable read is implemented as a snapshot at database level in MySQL, you can use repeatable read as a method to create an image of the database. The problem with logical backups is that rebuilding or restoring the backup can take really a long time because you need to reinsert all the data and you need to recreate all the database structures, indexes, and so are really good for partial recovery. It's very easy to recover just one table. Usually you have a readable, human readable copy of the data, which is very good. For example, if you need to make a partial recovery, but not in the sense of recovering one table, but in the sense of recovering a bunch of rows from one table, okay? In MySQL, the impact is really low, so it's just one query that runs. And the last thing is that you need a living instance to recover. So you need to install MySQL, and you need to start MySQL and create a MySQL instance to recover the logical backup. Between the logical tools, the first one is the good and old MySQL dump. The problem with MySQL dump is just one thread, just one file. It's very easy to stream MySQL dump using netcat. So you can do MySQL dump, pipe, netcat, send to another server, and then apply it at the same time. You can use it also to dump only the table definitions. And there are options which are not really used very often, but are interesting. You can, for example, generate delimited data using dash tab.
And actually, you can just dump the data also.
Mhm.
You can dump the schema or the data or both.
You can dump the schema and the data, or if you dump delimited data only, you just dump the data. And recovery can be very lengthy. MySQL pump is the first Oracle into have parallel dump. It has some interesting features. For example, MySQL dump dumps or used to dump the user table. Instead, MySQL pump dumps the user creation sentences. Okay. It supports compression. It supports advanced object filtering. You can define patterns for filtering, but the problem is that it is not valid for creating a replica because it does not return the position. So in theory, it's consistent, but yes. MyDumper is an open source tool. Actually, there are two tools, MyDumper and MyLoader. It's actively maintained by the community. And I say actively because it's a project that has been sleeping for some time, but now it's quite active, and some interesting features have been added recently. It allows you to perform parallel backup. It allows you to perform parallel restore. It allows you to make a consistent backup. You make filter the tables and the objects you are going to process using Perl-compatible regular expressions. It generates multiple files, and it also allows you to stream the backup. The way the backup is streamed is quite interesting because what MyDumper does is it performs the backup in parallel locally, generates the files locally, and then there's a thread that takes every file and sends it to the destination. Okay, so there's an additional thread that takes care of the streaming.
So is the stream single-threaded?
Yes, but the stream is always single-threaded because usually it's the network. So yes, yes, but in the case of MyDumper, there's a specific thread for the streaming. MySQL shell, it has a set of utilities to dump load tables, schemas, and instances. In the case of the export, it supports multiple formats. This means that the data is exported and you can define the delimiters and things like that. It also supports things like rate limits to avoid loading too much the server. It also supports storing in S3 compatible storage. It can make consistent backup, and the utilities are, there are different utilities. You have load dump to load a dump, and then you can dump an instance, you can dump schemas, you can dump tables, and you can export. That is the one that generates multiple dialects. TSV is tab separated values. Physical backups perform file or block-based operations to do the backup and the restore. I divide the physical backups in two types. The ones that have awareness of the database and the ones who don't have awareness of the database structure. So the snapshots are the main hot backup, physical hot backup that exists. But as we said before, they are not aware of the database. They perform the snapshot the same way. And for example, they don't check if all the files belong to the same snapshot. This is something you have to program separately. And also, if for whatever reason you are forced to have files into different storage types, then probably creating a snapshot will become something impossible, or at least very difficult.
So in that case, though, if it is on two different storage devices, if you freeze the file systems, then it should be okay, right?
But how you make sure that you are freezing in the same moment of time?
The same way.
Moment of time.
Well, I'm flushing the disk.
The two disks, you flush one and then flush the other. They are not consistent anymore. It's like copying the okay. And well, between the hot backup, physical hot backup tools, we have Percon Extra Backup, we have MySQL Enterprise Backup, and we have the clone plugin. What does awareness mean? Each database page has a LSN. This is the last sequence number. It just tells us the number of bytes written into I was going to say the binary logs, no, it's into the InnoDB logs. So it's quite simple. It's a number that it always grows, and it is used to identify if a page or a block is newer or older than another. Okay. If we are aware, we can make an inconsistent backup and turn it into consistent. And for each log entry that we have, we can compare the database blocks and say, okay, this log entry needs to be applied or not. Why do we need this? We need this because in the database, lots of changes take place at the same time. So we have concurrency, lots of transactions with different lengths are executed in parallel. What happens when there's a crash? When there's a crash, we have a bunch of transactions that were committed and some transactions that were not committed. And we also have information stored in the log files. So with all this information, we are able to perform the recovery operation and roll back the yellow transactions that did not complete. So this is the situation when we boot after a crash. And I was explaining this because when we perform a backup, we do exactly the same. We finish the backup in one moment of time. So instead of having the crash here, we could say backup end. And when we restore the backup, what we do is we remove the partial transactions. Okay? The Percona extra backup, I like to call it the Swiss Army knife of MySQL backups because you may do almost everything. You can perform a full backup, you can perform an incremental, you can perform a partial restore, you can encrypt your backups, you can make backups to the cloud, you can compress the backups. It's portable. You can make a backup from one technology and, sorry, from one operating system and move to another operating system as long as they are little endian or big endian both the same. Okay. So, for example, I've been using extra backup to restore backups on Windows. Okay, even if there's no version of Percona extra backup for Windows, because you
can use it to go cross between Windows and Linux.
yes, you need to do some tricks, but you can do it. You can do it because the InnoDB files are compatible. So as long as you have a Linux machine where you can see the volume, the Windows volume, you can. Okay. You can stream backups. It's compatible with Oracle MySQL and Percona Server for MySQL. It used to be compatible with MariaDB, but that's no longer true. And it's free open source. To make a backup, we take the following steps. First, we make the backup. After that, we prepare the backup. Preparing the backup is what I showed yesterday, is applying all the changes and then rolling back all the transactions that were cut in the middle of the end of the backup. And then we can restore the backup wherever we want. The next tool is MySQL Enterprise Backup. It's a licensed software. It's multi-platform. It supports Unix, Linux, and Windows. It also supports backup to tape using Oracle technology. And it also supports, and this is really very interesting, binary and relay log backup. So when you perform a backup, you can also copy the binary logs and the relay logs. This also can be done with my dumper.
I have a quick question about applying the logs to make the backup, the extra backup consistent. I don't remember. Would you do it at the backup time or only if you need to restore?
Usually you do it when you need to restore.
But you could do it at the backup time, which would
No, you could do it after the backup. You can run the prepare.
so that if you ever do have to restore, you're reducing your recovery time.
Yes, but you can you can do a partial prepare because this way you can do incrementals. Okay, in the prepare stage you do two things. You do the apply logs and then you do the rollback of the pending transactions. Okay, there's an option that is just apply and don't do the rollback. Okay, backups you can still apply them. Okay, and the way InnoDB logs are being treated is changing. So, for example, now the new versions are already able to dump the InnoDB logs. So the dump that extra backup did originally is no longer needed. You can start the backup and use the dump provided by MySQL. This is a new. When you make a backup using extra backup, usually what you do is you copy the data files, and also you need to copy the redo logs, the INODB logs. This is no longer needed. Why? Because you can tell MySQL to do it, to copy the INODB log somewhere. This is a new feature. So it allows you to, so you just need to, this is why I said before that this is changing. And probably this means that in the future we will have a sort of INODB logs based replication. Because otherwise it makes no sense to implement this. Well, it makes sense for the enterprise backup, but if you want to create an INODB, real INODB cluster, then you use these two for replicating stuff, okay? The last, but not least, is the clone plugin. It's mostly used to rebuild instances in group replication, but it also allows local cloning to a directory. Don't try this approach. Test and document your recovery procedures. Disasters always happen in the worst moment. And when there's a disaster, you need time to decide. You don't have time to do research or learn how to restore. And also something very important, if the crisis is huge, you need to involve business, because if the backup will take 3 days to restore, probably you need to decide the order you restore, and you need to make some compromises that are beyond the job of a DBA. I enjoy saying that the backups are like the Schrödinger cat, because a backup can suffer of quantum superposition. It was completed successfully, and you can restore it in a relevant time. What does this mean? Maybe it takes too long to restore. If you made the backup using MySQL dump, or it's an incremental backup, and you say, okay, I make a full backup every month, and I do incrementals every hour. Well, restoring this will take a long time, for sure. Or there's something missing in the backup. Or there's a bug in the backup software. And this happens, unfortunately, quite often with the new policy of MySQL of implementing future changes in minor versions. We've seen with Percon Extra Backup that actually we were forced to add a feature that does not allow you to perform a backup on a version of MySQL higher than Extra Backup.
And that applies to the point release. And that applies to the point release. So extra backup has to be updated with every single point release. Is that what you're saying?
It has to be. It has to be. You can say, go ahead and make the backup. You can, but as a default, it checks the version. And it does because we discovered one feature that made backups complete successfully, but they were not able to be restored due to one change that MySQL added. Okay? Or something as stupid as the infrastructure is not available. So sometimes you make backups, but you don't have a support contract. And your on-premise server crashes, and then the provider says that it will need 3 weeks to deliver a server like this. Okay? Questions? I've been quite quick.